Hey Math 20-1s. Today we're going to look at the law of cosines. Alright, like last day, we solved a triangle that didn't have any right angles in it. We're going to do the same thing today. Non-right angle triangles. Let's say we've got this example, triangle ABC. Draw a diagram, label it. Again, I think you have this in your notes. So we know these things. From what we've learned, I can't use right angle trigonometry. There's no right angles in this. And I can't use the law of sines because there's not a complete ratio. I know two sides, but I don't know any angle opposite those, and I know one angle, but I don't know the side opposite it. So what are we going to do? Well, last day when we were talking about the law of sines, we drew a perpendicular, so we made it into two right angle triangles. So let's do that again. And let's identify some new variables. Let's say that's the height of the triangle. Let's call the distance from A to the right angle a length of x. And then the distance from B to that right angle would have to be 11 minus x. Makes sense. Let's write the equations using Pythagoras' theorem. I now have two right angle triangles. So in the first right angle triangle, I would say that 7 squared equals h squared plus x squared. And in the second right angle triangle, I would say that a squared equals h squared plus 11 minus x squared. All right, so I've got two equations based on Pythagoras' theorem for two right angle triangles. What we're going to do now is simplify the system of equations. Remember from grade 10 we can simplify these a bunch of ways, but if I use elimination, I come up with this equation. So if I'm going to subtract these two equations from each other, so I use elimination, I subtract the two equations. A squared take away 7 squared, there we have it. H squared minus h squared will be gone, and then I've got 11 minus x squared, subtract x squared. So my h squareds, if I subtract these two equations, disappear. This is an equation I've got left just in terms of a and x, so my h's have disappeared. I might now write it like this. I can expand out the 11 minus x all squared. So I square the first term, 11 squared. I multiply the two terms together, 11 times x, and I double it. And then I square the second term, negative x times negative x is positive x squared. I go ahead and simplify that equation a bit more. I know that x squared minus x squared disappears. And I'm going to add 7 squared to both sides. So I get 7 squared plus 11 squared minus 2 times 11 times x. Looks interesting, but I still have two variables, a and x. Not really going to help me solve for a if I don't know what x is. So let's try something. Let's use trig to write an equation for x. From 28 degrees, I know the adjacent side is x, and I know the hypotenuse is 7, so I could actually solve for x. I could use my right angle trigonometry and cosine of 28 degrees. So cosine of 28 is adjacent x over hypotenuse 7. I could solve for x by multiplying both sides by 7. Well, I could figure out the actual value, or I could just substitute this value in for x in the equation I've got over here. So I could take 7 times the cosine of 28, plug it in for x, and the equation looks like this. A squared equals 7 squared plus 11 squared minus 2 times 11. And instead of x, I know x is now 7 times the cosine of 28. If I go back and look at my original equation that didn't have an h in it, didn't have any x's in it, I've got the sides 7 and 11, and I've got my angle 28 degrees, and that's all I need to find side A. My two sides, 7 and 11, here they are, 7 and 11, my angle of 28 degrees. I can now solve for A. So this is some calculator work. Let's solve for A. And we should come up with about 5.8. Now again, that's a lot of work. And do I have to go through these steps every single time I see an equation? Or sorry, I see a triangle that doesn't have a right angle in it and that I can't use a sine line? Absolutely not. But this is how the cosine law was developed. And we will use the cosine law from now on in these situations and not have to go through all those steps. So given an oblique triangle, my cosine law would state a squared would equal b squared plus c squared minus 2bc multiplied by the cosine of angle A, which is opposite the side we're looking for. All right, so notice where the side I'm looking for might be A. I need to know the angle opposite that. I would then know sides B and C as well. All right, this law can be written in many ways. Maybe I'm looking for a little side B. All right, if I'm looking for a little side B, then it's going to be b squared equals, I would know sides A and C, so a squared plus c squared, and I would know angle B, so minus 2ac times the cosine of angle B. Or if I'm looking for little side C, we could rewrite it again as c squared equals the two sides we know, a and b, so a squared plus b squared, minus 2 times ab times the cosine of the side opposite, of the angle opposite the side we're looking for. All right, so depending on what side you're looking for, it will always be over here, and you must know the angle opposite that side. So given this situation, I'm going to find little side B. So anytime we're looking for an unknown side, and I want to use the cosine law, we need to know the other two sides and the enclosed angle. So the angle between those two sides we know. If we have this situation, we can use the cosine law. The sine law is a little simpler, but again, I haven't got a complete ratio in this triangle, so I cannot use the sine law. So let's use the cosine law. I'm looking for B, so my cosine law would look like this. So I just have to substitute in my cosine law. I don't know what B is. I know little a is 230. I know little c is 150. And I know angle B is 43 degrees. So I substitute into my equation, and I'm solving for b squared now. So this is calculator work. We go ahead and come up with the right side of this equation equal approximately 24,936.59. Remember, that's b squared. That side would be way too large in this triangle. That wouldn't make any sense. So to find b, I must take the square root of that number. So b is around 157.9 meters. All right. In this triangle, I'm looking for a little side A, the unknown side. Again, I've got two sides, the enclosed angle. I would use my cosine law looking for little side A. Let's substitute in. B is 43, B is 61, C is 43, and angle A is 38 degrees. So we just have to substitute in this equation. Work out the right side of this equation, about 1,435.09. Again, that wouldn't make sense in this triangle, but that's the side, or that's the value for a squared. So to find little a, I must take the square root of both sides. So a is approximately 37.9 centimeters. All right. So if we're looking for an unknown side, we must know the other two sides and the enclosed angle. We can use the cosine law. We can also use the cosine law to find an unknown angle. So let's find the measure of angle A in this triangle. So I'm looking for angle A. I know all three sides. Well, if I'm looking for angle A, the only cosine law statement that has angle A in it looks like this. So if I'm looking for angle A, I want to solve this equation for the cosine of angle A. So I'm going to move the a squared to this side, and I'm going to add the 2bc cosine A to the other side. So add 2bc cosine over here and subtract a squared over there. And then I'm going to solve for cosine of A by dividing both sides by 2bc's. So the cosine of A is going to equal b squared add c squared minus a squared over 2bc. Now that I know this equation, I can find angle A, which is what it was asking me to do. So a little manipulation of the cosine law, I can now find an angle. So from angle A, side A is 38, I can plug that in. Side B is 61, side C is 43. I plug those sides into this equation, and I'm going to get a decimal value over here on the right side of the equation because that's the ratio for cosine of angle A. So to find angle A, I must go second function cosine of this ratio. All right. So we can do all this work in our calculator. There are the steps you want to do. Find out angle A is approximately 38 degrees. Let's try another one, trying to find an angle in a triangle. So given triangle DEF, let's find angle E. Again, I'm not given a cosine law using D's, E's, and F's, but I can apply it. If I'm looking for E, angle E, then I'm going to make my cosine law have sides D, E, and F in it. So little e squared would equal D squared plus F squared minus 2DF times the cosine of angle E. All right, so that cosine law is the same, doesn't matter what our triangle is labeled as. I'm looking for angle E, so I want to make E squared all by itself on the left side. Again, I rearrange this equation to solve for the cosine of E. There we go. Now I just have to plug in the unknown, or the known sides. So little e is 85, little d is 64, and little f is 78. So we substitute in this equation, do a little calculator work. Again, the right side will give me a decimal value. I'll go second function cosine of that decimal value, and I get angle E is approximately 73 degrees. All right. That's all there is. Finding angles, finding sides using the cosine law. We will work on this stuff in class tomorrow. Till then.